In this video, I'd like to overview the idea of median and quartiles. And I first want to present a broad overview before I get into the nitty-gritty calculations. And there are sometimes students who are so focused on the minor calculations that they lose sight of the big picture. So that's where I really want to start. And so I'm starting with some data sets, and I've got 4 different data sets, and we'll demonstrate why in a minute. But I first want to start with this set that has only 6 values in it. And when we find the median, we're trying to find the middle value, and they're all in order from smallest to largest. So when we look for the middle value, we see there are actually 2 middle values. And because it's an even number, we take the midpoint of those two, and so we end up with 66.5 or 66.5. And so that's our median. And then when we start to think about the quartiles, what we're thinking of is the quarter markers. So the lower quarter marker is the halfway point of the lower half. And so if I start from scratch here and think, where's my upper half and my lower half, I see the first 3 values are going to be the lower values, and then the midpoint of these 3 is going to be 64, and so that's going to be my first quarter marker, or my Q1. And then we'll do the same thing for the upper quarter marker. So again, we split this data set in half, and then we end up with this value here in the middle. Again, so if we look from top to bottom, and then our middle value is 69. And so that's what we end up with again for our Q3. And what we find is that for even number data sets, so here I've got n equals 6 and n is equal to 8, the formulas that are used by some of the commonly used technologies such as StatCrunch or the TI-84 calculator, for even numbers in the data set, it seems that the formulas apply if we use this sort of generic overviewing method. So when we look at this data set, which has 8 values, here's the middle, and our median again is the midpoint of the 2 middle values, again because there's an even number of them. And so our median is again going to be, in this case, 68.5. And now when we look at the lower half of the data, this time we can take the midpoint of the lower half of the data, and we end up with 64.5. And we also take the midpoint of the upper half of the data, and we end up with, in this case, 69, because both of the values are the same. Now, if you compare this to some of the common technology such as StatCrunch or the TI-84 calculator, you're going to find that there's a relatively good agreement here. So I want to bring up StatCrunch. And here I've got these 4 data sets in StatCrunch, and I can perform some summary stats so you can see the output down here, but I just want to step you through those calculations. So if I ask for stat and then summary stats, and I ask it to perform some of these calculations such as the median, the Q1 and Q3. So I've got these different values of n, and I'm going to select all 4 columns for n is 6 through 9. And so again, the values that I really care about are Q1, and let's put these in order. So then also the median. And finally, I will do this calculation of Q3. And when I hit compute, I end up with this data table, which is the same one that I've got shown here from previously calculated. But what you see is that the values for n equals 6, the Q1, the median, and the Q3 are the same. So we've got for our n equals 6, we've got Q1 is 64, our median is 66.5, and our Q3 is 69. For our n equals 8, we've got for our Q1 64.5, and then for our median 68.5, and then for our Q3 we've got 69. So these values align with what we had calculated manually. So next I want to show you the TI-84 and some of those numbers that we get for. So here's my TI-84 calculator, and I have previously entered the data into these 4 lists, L1 through L4. And so I want to perform these calculations on the first and the third list, which are the ones that we had done manually. So let's go to Stat, and I don't need to edit because the data is already entered, but let's do calc 1 variable statistics. And so we're going to enter, and I do want what's in L1, so I'm going to first select L1. And now when I hit enter and calculate, this is the information I see. And to get more information, I need to hit this down arrow, because you can see there was this Q1, and then it's got median, and then Q3. So now I have the numbers that I was looking for. And for n equals 6, which was what was in the first list, we see that Q1 is equal to 64. The median is 66.5, and Q3 is equal to 69. We can do a similar type of calculation on the third list, which had 8 values in it. So let's go to calc, and I want to select my list. So first, let me just show you again what the lists look like. So L1 had n equals 6, L3 had n equals 8. So that is the list that we're going to select. And now when we perform the statistics on it, we do calculate, or calc 1 variable statistics. And this time I'm going to select L3. So I'm going to use the second button and hit 3. And now when I perform that calculation, we can see the numbers. And again, we only get Q1, but we can scroll down, again, push the down arrow to get a couple more numbers. And so we see that Q1 is equal to 64.5. That's what we got over here. And the median is 68.5. And the value for Q3 is 69. So those are all consistent with what we calculated through our sort of rough middle of the middle definition. Okay. So this all works great when you have n is an even number, but when n is an odd number, you may get some small discrepancies. And this is one of the horribly frustrating things about the different types of technology and the methods that they use for performing their calculations. And so again, you may have a certain data set, and it produces different values depending on the technology that you use. Okay, so let me step through some of the ideas that we use to perform this calculation. So again, we're back to our data. And here we have 7 values, so n is equal to 7, and then in the last column we have 9 values. So this is what happens when you have an odd number of values. So when we start off finding the median of a data set with an odd number of values, that's pretty straightforward because there's only one central value. And so in this case, when n is equal to 7, we take the 4th value, and that's the median. And in the case where we have 9 values, the middle value is that 69. So the part that becomes challenging is when we want to find the quartiles, and if we think sort of generically as the middle of the lower half, the question is, do you include the median or do you exclude the median? And it seems that the exclude paradigm is a little bit more commonly used, so we could either exclude or include. And I want to show you what happens if we exclude the median. So in this n equals 7 example, if we just sort of ignore that value for the purpose of calculating our Q1 and Q3, what happens is then we see that in the lower half there are 3 values, and this 64 is very straightforward, and that is our value of Q1. And then in the upper half, we see there are 3 values, and the middle of that upper half is again, just going to be that single value of 69, and that'll be Q3. Now, when we go over to n equals 9, we've excluded the median, but now we have 4 remaining values in that lower half. So if we were to choose the midpoint of those 2 values, we're going to end up with Q1 is equal to 64.5. And for the upper 4 values, then if we choose the midpoint, we see that it's going to be the midpoint of those 2 middle values, 69 and 70. And so Q3 is equal to 69.5. So now let's take a look at the TI-84 calculation. And we've got the n equals 7 data stored in L2. So we're going to do a calculation on that. So calc, one variable stats. And this time we will choose L2, the second list. And when we perform the calculation, let's scroll down to see what those values are. We can see that Q1 is equal to 64, as we had in our center of the lower half. And the median is also 68. And the center of our upper half, our Q3, is 69. And so the TI-84 calculation is consistent with this paradigm that we used. Now let's take a look at the last column. So this is our L4 data. So just to look at it one more time. Again, in L4, we have the 9 data values, and we're going to perform that statistical calculation. One variable stats and L4. And so when we hit calculate, we see that Q1 is equal to 64.5, and that's what we had done, gotten when we used the exclusion of the median. The median value is 69, and Q3 is 69.5. So you can see how the TI-84 calculator is able to arrive at these values. Next, I want to take a look at StatCrunch and see how its calculations compare to what we have done. And so if you look at the calculated values that we had used before, we actually did it twice, but for n is equal to 7, we had the median was 64, and when you compare that, or excuse me, the Q1 is 64, and we did get that value by our calculation. We see that the median is, again, for n equals 7, the median is 68, and so that also matches. And again, for n equals 7, the Q3 value is 69. So far, so good. But when we go to n equals 9, so the last row of data, we can see that the lower value, the Q1 value, comes up at 65 using StatCrunch, and then 69 using the median, and then 69 instead of 69.5. So these values, the Q1 and Q3 values, differ from our calculation manually where we excluded the median. So the question is, how did StatCrunch get these values? Now, if we included the median, we would not necessarily do any better. So let's see what happens if we find those Q1 and Q3 values again by including the median. So I'm going to erase all this stuff, but again, we'll choose the middle value as the median. And now, if we include the median in the lower half, so then what we have is our lower half would be 4 values, 58 through 68, and our Q1 value is supposed to be 64.5. But that does not match what we get with StatCrunch. So when n is equal to 7, Q1 is listed at 64. And then if we included that middle value, or the median value in our list, and then we chose the midpoint of the two center values, that value would be 69. And our Q3 is equal to 69. So that one is correct. But this one is a little red flag here. This again differs from our StatCrunch value. If we go to the n equals 9 case, then if we chose to include that middle value, that means the lower half would have 5 values. And then we should say that Q1 is equal to 65. And if we choose the upper half, including that middle value, we would say the middle of the upper half would be 69, and then our Q3 would be equal to 69. And when we compare that to StatCrunch, this time these values are consistent with StatCrunch calculations. So Q1 is 65, Q3 is 69. But that n equals 7 case does have a difference. And so it seems that StatCrunch is not using this methodology. So what in the world is it doing? Well, if you look at the Pearson texts, for example, Triola's Elementary Statistics, 14th edition, which is what we're using now, you'll see that there are certain formulas that are given, which I'm going to lay out for you. So we've considered the paradigms of including and excluding the median. And now when we want to look at the paradigm which is used by StatCrunch, we're looking at these formulas which are contained in some Pearson texts, including Triola. And in this case, we don't need to find the percentile because we know that for Q1, the percentile is the 25th percentile, and for Q3, that the percentile is the 75th percentile. But again, these formulas kind of go as a pair. What we're trying to do here is to find the value that's located in a certain position. And so, for example, for Q1, again, that's the same as the 25th percentile. And so what I'm trying to do is let k equal 25. And you can see 25 out of 100, that's a fourth. So in my case, when n was equal to 7, what I had was the locator. I would take that 25 out of 100, again, which is a quarter, times my 7, and that would give me 1 3/4 or 1.75. Now what we're supposed to do is, since L is not a whole number, we are going to round up to the next whole number, and so that would be 2. So the position that I'm looking for is what's in position 2. So when I find Q3, it's going to be similar. This is going to be the same as the 75th percentile, so K is equal to 75. And then same thing for n is equal to 7. We'll find our locator, and this time 75 out of 100 times n of 7 is going to give me 5 1/4 or 5.25. Again, we will round up, and even though 5.25 is less than 5.5, we take that fractional part and round to the next integer, so that's going to be 6. And so I'm looking for position 6. So I'm going to find those quartile positions for my other data set where n is equal to 9, but we'll do similar calculations. So for Q1, we'll find our locator, which is at the 25th percentile out of 100, and then this time times 9. So that's going to give me 2.25, and that's going to round up to 3. So I'm looking for position 3. And finally, for Q3, we have then the locator, which at the 75th percentile, and we'll multiply that times 9, which gives us 6.75, and that's going to round up to 7. So that'll be position 7. And now I'm going to take that information and compare it to my StatCrunch results. So going back to the data, I'm looking for at n equals 7. In this column, what's in position 2 is that number 64 for my Q1. And what's sitting in position 6, again for n equals 7, is that number 69. And if we look at n equals 7, we can see Q1 is 64 and Q3 is 69, just as we expected. And then if we look for n equals 9, so when n is equal to 9 in position 3, we can see that number 65. And in position 7, again for n equals 9, we end up with the value of 69. So when we compare the results with the n equals 9 data, you can see Q1 is equal to 65 as we got before, and Q3 is equal to 69. So we can see that using these formulas to compute the quartile values is consistent with the results that we get from StatCrunch. On one hand, these computations are tedious and they take a lot of time and thought. On the other hand, StatCrunch will do the crunching for you. It feels no pain, and so it comes with these values. But for a more overall feel of finding quartiles, if you think of the first quartile as being the middle of the lower half, and the third quartile as being the middle of the upper half, and it is more common to exclude the median than to include it, that's a pretty quick way that we are able to get those values. And when n is even, or when n is large, we don't really have to pay attention to these special concerns because the discrepancies are not going to show up in our calculations.